أخبار اليوم.
Okay, that's fine. Let's now shift to the fourth question. We have here first part in that question, compare between X-rays and laser in terms of coherency of their photons. Remember, in Sudan exam, they mentioned the comparison between X-rays and laser, but in terms of wavelength. So that is a very important comparison and complete it. So in this part, we are going to compare between X-rays and laser in terms of coherency of photons. Yes, right. Coherency of X-rays photons are incoherent, emitted at different times and propagate at different phases. But in case of laser, since they are emitted by stimulated emission, so they are emitted at the same time and propagate having the same phase, so they are coherent. Incoherent photons, coherent photons. The second or the next part, compare between AND gate and OR gate in terms of transistors content. So what is the relation between AND gate and transistor? AND gate is composed of a transistor having more than one emitter, or we can say two transistors connected in series together. OR gate is two transistors made in parallel with each other. So OR gate is composed of two transistors connected in parallel. Number three, Fleming's right-hand rule and Fleming's left-hand rule in terms of use. In fact, Fleming's right-hand rule in the induction part. But Fleming's left-hand rule, it is in the magnetic effect of the electric current. So let's start with Fleming's right-hand rule. It is, yes, to find the direction of the current induced through a straight wire, when that wire is moved in a magnetic field. But Fleming's left-hand rule is used to find, to find the direction of the force. You're right. Direction of the force that affects a wire carrying a current and placed in a magnetic field. That is the answer of the third part. The fourth part, electron microscope and optical microscope in terms of the characteristics of the formed image. In fact, in case of electron microscope, the image is a real image formed on a fluorescent screen or photographic plates. On the other hand, in optical microscope, the image is virtual, can be seen directly by the naked eye. That is the optical microscope. Finally, in that part of comparison, bracket series and Paschen series in terms of frequency of emitted photons. In fact, both series emit wavelengths in the infrared region, but bracket emits wavelengths shorter. So bracket series emits photons with longer wavelength. Longer wavelength means lower frequency. So bracket series emits photons of lower frequency. Paschen series emits photons of higher frequency. Let's answer the second part. Write down an equivalent unit for each given unit and then mention the physical quantity. So we need an equivalent unit and mention the physical quantity measured. So as you see, underline the parts of the question to not to forget any part of it. So the first unit here is Newton ampere -1 meter -1. That is very easy. Newton per ampere meter is the Tesla. So the answer here is the Tesla. And Tesla, of course, to measure the magnetic flux density at a point. Kilogram meter square second -2. That is for Planck's constant, right? Planck's constant. Because Joule, you need to know that Joule is equivalent to kilogram meter squared second -2. So that is the Joule. So Joule second, which is Planck's constant unit, so second -2 with second, so it becomes second -1. But you have to know that Joule equals kilogram meter square second -2. That is equivalent to Joule second, which is the unit of Planck's constant. The last one may be new to you, Henry meter -1. But you know Henry. Henry is volt second per ampere. Volt second per ampere. That is Henry. And meter -1 means per meter. And the volt second, if you know that, that is the Weber. So that is the Weber per ampere meter. That is, as you see, the permeability of the medium to magnetic flux, Weber per ampere meter. That is the equivalent unit, and the quantity measured is the permeability of the medium to magnetic flux. The second part of B, write down one characteristic of. Magnetic field produced by an electric current through a solenoid. We need a characteristic, a property for that magnetic field. As you see, I read the question many times to understand, to get the idea. So magnetic field produced by an electric current through a solenoid. So that field is similar to the field of a bar magnet. That is the characteristic can be written here. Connection of resistors in parallel. You have many characteristics in that point, but the most important one, the total or the equivalent resistance for some resistors in parallel is less than any of the resistances in the group. The ohmmeter scale, what a characteristic for the ohmmeter scale? Yes, one of the most important characteristics here, the ohmmeter scale is non-uniform or not linear. That is the last part in question 4. The figure illustrates the variation in the value of current, generated by AC dynamo during 40 milliseconds. So here that value is 40 milliseconds. What is required is to find the angular velocity of the dynamo coil rotation. Angular velocity is omega, as you know. So how can we get omega from that graph? Of course, this point is very important. That is the time of one cycle. That is the periodic time. So the periodic time is 20 milliseconds. The periodic time here is 20 milliseconds. So frequency equal 1 over periodic time. So equal 1 over 20 times 10 to the power negative 3. So the answer is 50 hertz. So now we have the frequency. When you get the frequency, you can get the angular velocity. As you know, omega equal 2 by f. So by 3.14 here. 3.14 and the frequency is 50. So you can find the angular velocity. And remember, the angular velocity is in radian per second. That is very important, radian per second. The next part of the problem, what is the effective value of the current? That is the maximum value. 20 amperes. But here we need the effective value. To find the effective value, we are going to multiply 0.7, sorry, we can remove it. So we can write 0.707 multiply 20, you get the effective value of current. From this given current, that is maybe a new question to you. Maybe it is a new question to you. How can you convert that current to that current or that current? So how can you obtain each of the currents represented by figures A and B from the given current? To convert that current to that current. In fact, that is alternating current, AC current. And that is also alternating current, AC current. But how can you convert that to this? 20 amperes to 10 amperes. Yes, right. To lower the value of current, you need to use step-up transformer. Step-up transformer. Because step-up transformer is used to increase the voltage, up the voltage, but down the current. So to convert that current to that current, you need to use step-up transformer. Step-up transformer or any transformer, the input is AC, the output is AC. But how can you get this current? This current is called half-wave rectified current. Yes, right. That is when you use PN junction. So when you use PN junction, you can convert the AC current into or half-wave rectified current. So PN junction, when AC current passes through the PN junction, it becomes half-wave rectified current, and that is the end of question 4.